It is not acceptable to label incorrectly wired wall lights from overseas. The reason is that incorrect wiring poses a safety hazard as it can lead to electrical shocks or fires. Labeling the wires does not correct the underlying problem and may confuse future individuals who work on the fixture. The correct solution is to rewire the fixture according to the correct color code or polarity. This involves firstly identifying the correct hot lead, usually black or red, and neutral lead, usually white. Secondly, reconnecting the wires to the appropriate contacts in the fixture socket. Thirdly, ensuring that the fixture is properly grounded, using a green or bare copper wire. Once the fixture is rewired correctly, test it to ensure it is functioning properly. Proper wiring is crucial for electrical safety. Incorrect wiring can lead to electrical shocks, fires, damage to the fixture or equipment, and malfunctions. It is always advisable to seek professional assistance if you are not comfortable working with electrical wiring. When working with electrical wiring, always disconnect the power source before starting any work. Use appropriate tools such as insulated screwdrivers and wire strippers to avoid electrical shock. Wear safety glasses to protect your eyes from debris. Check the voltage of the circuit with a multimeter before working on it to ensure that the power is off. Follow the National Electrical Code or local electrical codes for all wiring installations. Never overload circuits by plugging too many appliances into a single outlet. Use extension cords sparingly and ensure they are properly rated for the intended use. Inspect electrical cords regularly for damage and replace them if necessary. Keep electrical outlets and appliances away from water to prevent electrical shock. Install ground fault circuit interrupters, also known as GFCIs, in areas where water is present, such as bathrooms and kitchens. Use arc fault circuit interrupters, also known as SIs, to protect against electrical fires caused by arc faults. Educate yourself and others about electrical safety practices to prevent accidents. If you are unsure about any aspect of electrical work, consult a qualified electrician. Remember that electricity can be dangerous, and it is important to take precautions to protect yourself and others from harm. When identifying the hot and neutral leads, use a voltage tester to confirm the polarity. The hot lead will typically show a voltage reading when tested against ground, while the neutral lead will not. When reconnecting the wires to the fixture socket, ensure that the connections are secure and that the wires are properly insulated. Use wire connectors, such as wire nuts, to join the wires together and wrap electrical tape around the connections for added insulation. When grounding the fixture, connect the green or bare copper wire to the grounding screw in the fixture or to the metal junction box. This provides a path for stray electrical current to flow back to the source, preventing electrical shock. After rewiring the fixture, test it with a circuit tester to ensure that the wiring is correct and that the fixture is properly grounded. If the circuit tester indicates any problems, such as an open ground or reverse polarity, correct the wiring before using the fixture. Regularly inspect electrical fixtures and wiring for signs of damage or wear, such as frayed wires, cracked insulation, or loose connections. Replace any damaged components promptly to prevent electrical hazards. Keep flammable materials away from electrical fixtures and wiring to prevent fires. Use surge protectors to protect sensitive electronic equipment from voltage spikes. Install smoke detectors in your home to provide early warning of fires. Test smoke detectors regularly and replace the batteries as needed. Develop a fire escape plan for your home and practice it regularly. Keep a fire extinguisher in your home and know how to use it. If you experience an electrical shock, seek medical attention immediately. Never attempt to repair electrical equipment while it is plugged in. If you are working on a ladder near electrical wires, be aware of your surroundings and maintain a safe distance. Avoid using electronic devices while taking a bath or shower to prevent electrical shock. Keep electrical cords out of reach of children and pets. Use tamper-resistant outlets to prevent children from inserting objects into the outlets. Teach children about electrical safety and the dangers of playing with electricity. Follow all manufacturers' instructions for electrical appliances and equipment. Have your electrical system inspected regularly by a qualified electrician. Address any electrical problems promptly to prevent them from escalating into more serious hazards. By following these safety precautions, you can reduce the risk of electrical accidents and protect yourself and others from harm. It's important to understand basic electrical concepts such as voltage, current, and resistance. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of electrical current. It is measured in ohms. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. Understanding Ohm's law can help you troubleshoot electrical problems and ensure that your electrical circuits are operating safely. Series circuits have components connected in a single path, so the current is the same through all components. Parallel circuits have components connected in multiple paths, so the voltage is the same across all components. The total resistance of a series circuit is the sum of the individual resistances. The total resistance of a parallel circuit is calculated using a more complex formula. Electrical power is the rate at which electrical energy is transferred. It is measured in watts. Power equals voltage times current, or watts equals volts times amps. Electrical energy is the amount of electrical power used over time. It is measured in kilowatt-hours. Understanding these basic electrical concepts can help you make informed decisions about your electrical system and ensure that it is operating safely and efficiently. Additionally, consider the type of bulb used in the wall-mounted light. Different types of bulbs have different wattage requirements. Ensure that the bulb used is compatible with the fixture's rating. Using a bulb with a higher wattage than the fixture is designed for can overload the circuit and create a fire hazard. LED bulbs are energy efficient and produce less heat compared to incandescent bulbs. Halogen bulbs produce a bright white light but generate a lot of heat. Incandescent bulbs are the least energy efficient and produce the most heat. When replacing a bulb, always disconnect the power source first. Let the bulb cool down before handling it to avoid burns. Dispose of used bulbs properly, following local regulations. Some types of bulbs, such as compact fluorescent lamps, also known as CFL, contain mercury and require special handling. When working with electrical wiring, it's also important to understand the different types of wire used in residential wiring. Non-metallic sheet cable, also known as NM cable or Romex, is commonly used for interior wiring. It consists of 2 or more insulated wires wrapped in a plastic sheath. Underground feeder cable, also known as UF cable, is used for underground wiring. It is designed to withstand moisture and other environmental factors. Armored cable, also known as AC cable or BX cable, is used in areas where the wiring needs to be protected from physical damage. It consists of insulated wires wrapped in a flexible metal sheath. Conduit is a metal or plastic pipe used to protect electrical wiring. It is commonly used in commercial and industrial buildings. The size of the wire used in the circuit depends on the amount of current it needs to carry. The National Electrical Code, Article 310.15, provides tables that specify the ampacity of different wire sizes. Using a wire that is too small for the current can cause it to overheat and create a fire hazard. Always use the correct size wire for the circuit. When connecting wires, use the appropriate type of wire connector. Wire nuts are commonly used to connect solid wires. Crimp connectors are used to connect stranded wires. Push-in connectors are used to connect solid or stranded wires. Ensure that the wire connectors are properly sized for the wires being connected. When installing electrical outlets, use tamper-resistant outlets to prevent children from inserting objects into the outlets. Install ground fault circuit interrupter, also known as GFCI, outlets in areas where water is present, such as bathrooms and kitchens. Install arc fault circuit interrupter, also known as FSI, outlets to protect against electrical fires caused by arc faults. When installing electrical switches, use switches that are rated for the intended use. Single-pole switches are used to control a light or outlet from one location. Three-way switches are used to control a light or outlet from two locations. Four-way switches are used to control a light or outlet from three or more locations. When installing lighting fixtures, follow the manufacturer's instructions carefully. Ensure that the fixture is properly supported and that the wiring connections are secure. Use the appropriate type of mounting hardware for the fixture and the ceiling or wall. When installing ceiling fans, use ceiling fan-rated junction boxes. Ceiling fans are heavier than standard lighting fixtures and require a stronger support system. When installing recessed lighting, use recessed lighting housings that are IC rated. IC rated housings are designed to be in contact with insulation without creating a fire hazard. When installing outdoor lighting, use outdoor rated fixtures and wiring. Outdoor fixtures are designed to withstand moisture and other environmental factors. Use underground feeder cable, also known as UF cable, for underground wiring. When installing swimming pool wiring, follow the specific requirements of the National Electrical Code, Article 680. Swimming pool wiring is subject to strict regulations to prevent electrical shock hazards. Always use a qualified electrician to install swimming pool wiring. It's also important to understand the different types of electrical panels used in residential wiring. Main electrical panels are the primary distribution point for electrical power in a home. Subpanels are used to distribute electrical power to specific areas of a home. Circuit breakers are used to protect electrical circuits from overloads and short circuits. Fuses are also used to protect electrical circuits from overloads and short circuits. Circuit breakers are resettable, while fuses must be replaced after they blow. The size of the main electrical panel depends on the electrical load of the home. The National Electrical Code, Article 220, provides guidelines for calculating the electrical load of a home. Ensure that the main electrical panel is large enough to handle the electrical load of the home. When replacing a circuit breaker or fuse, use the correct size and type. Using a circuit breaker or fuse that is too large can allow excessive current to flow through the circuit, creating a fire hazard. Regularly inspect the electrical panel for signs of damage or wear, such as corrosion, loose connections, or overheating. Address any problems promptly to prevent electrical hazards. Keep the electrical panel clean and free of obstructions. Never store flammable materials near the electrical panel. Have your electrical system inspected regularly by a qualified electrician. This is especially important if you live in an older home with outdated wiring. Older wiring may not be able to handle the electrical load of modern appliances and equipment. Upgrading your electrical system can improve safety and prevent electrical hazards. When working with electrical wiring, always follow the National Electrical Code, Article 110.3. The National Electrical Code is a set of standards for electrical installations. Following the National Electrical Code, Article 110.3 can help ensure that your electrical system is safe and reliable. The National Electrical Code, Article 110.3 is updated every 3 years, so it's important to stay current with the latest changes. Consider the NEC tables to avoid hazards. Always prioritize safety when working with electricity. Never take shortcuts or compromise on safety. If you are unsure about any aspect of electrical work, consult a qualified electrician. By following these safety precautions and understanding basic electrical concepts, you can reduce the risk of electrical accidents and protect yourself and others from harm.